One enterprise AI agent made 2.3 million API calls in a single day, more than the entire human user base combined. Your API security was designed for humans. It's about to break. Welcome to AmtocSoft. I'm going to walk you through exactly why API security for AI agents is fundamentally different from what we've been building for the last 20 years. We'll cover the 5 critical differences, look at real authentication patterns that actually work, walk through rate-limiting strategies that won't just block everything, and finish with a practical checklist you can apply to your APIs today. Whether you're building agents or defending against them, this is the security landscape you need to understand. The first thing that changes is scale. A human user might make 50 API calls during a work session. An AI agent running autonomously can make 50 calls per second, and it doesn't stop at 5 p.m. Traditional rate limiting assumes predictable, human-paced traffic. You set a limit of 1,000 requests per hour, and that works fine for browser users. But an AI coding assistant analyzing a codebase will blow through that in 2 minutes. The problem isn't just volume. It's the pattern. AI agents make bursty, unpredictable requests. They might be quiet for an hour, then suddenly need to process 100 documents in 30 seconds. Your rate limiter needs to handle both the sustained throughput and the bursts without either blocking legitimate work or letting abuse through. Token bucket algorithms with sliding windows are the baseline, but you'll also need adaptive limits that adjust based on the agent's behavior over time. The second critical difference is identity. Humans authenticate with usernames, passwords, and multi-factor authentication. They get a session that lasts until they close the browser. AI agents don't have fingers to type passwords or phones to receive codes. They need machine-native authentication. The gold standard is OAuth 2.1 client credentials flow. The agent presents a client ID and secret, gets back a short-lived access token, and includes that token in every request. When the token expires, the agent automatically refreshes it. No human in the loop. For service-to-service communication, mutual TLS adds another layer. Both the client and server present certificates. This gives you cryptographic proof of identity on both ends. The worst pattern I still see in production is a static API key hard-coded in an environment variable that was created 2 years ago by someone who's no longer at the company. That key has no expiration, no rotation, and full access to everything. If an AI agent is using that key, you have no way to distinguish it from a compromised credential being used by an attacker. Difference number 3, authorization scope. When a human uses an application, they typically need broad access because their workflow is unpredictable. They might read emails, then switch to editing documents, then check analytics. AI agents are different. They have specific, well-defined tasks. A coding agent needs read access to your repository and write access to create pull requests. It does not need access to your billing dashboard. Least privilege isn't just a best practice for agents. It's a survival strategy. An overpermissioned agent that gets compromised gives the attacker everything. Implement fine-grained scopes. Use OAuth scopes like read repos and write pull requests instead of a blanket admin token. And audit what permissions agents actually use. If an agent was granted 10 scopes but only ever uses 3, revoke the other 7. Fourth difference, AI agents craft requests programmatically, which means they can be more precise than humans, but also more dangerous. An AI agent can construct perfectly formatted requests that exploit edge cases in your API schema that no human would think to try. Your validation needs to go deeper. Validate not just the shape of the request, but the semantics. Is this agent requesting an unusual combination of parameters? Is it accessing resources in a pattern that suggests data scraping rather than legitimate use? Content-based validation matters too. If your API accepts natural language inputs, an AI agent might send prompt injection attacks embedded in what looks like normal data. Schema validation, input sanitization, and behavioral analysis all become critical. The fifth difference is observability. With human users, you can look at session patterns and spot anomalies fairly easily. A user logging in from a new country, accessing files they've never touched before. Those signals are well understood. AI agent behavior is harder to baseline. Agents are supposed to make unusual requests. They're supposed to access lots of resources quickly. The signals that indicate compromise in a human context are normal for agents. You need agent-specific monitoring. Track each agent's behavioral baseline separately. Alert when an agent deviates from its own pattern, not from human patterns. Log every request with the agent's identity, the specific scope used, and the resources accessed. Build dashboards that show agent behavior over time so you can spot drift before it becomes a breach. Here's your practical checklist. Number 1, replace static API keys with OAuth 2.1 client credentials and short-lived tokens. Number 2, implement per-agent rate limits with token bucket algorithms that handle bursts. Number 3, enforce least privilege scopes. Audit and revoke unused permissions quarterly. Number 4, add behavioral monitoring that baselines each agent individually. Number 5, validate request semantics, not just schema. Number 6, implement mutual TLS for service-to-service agent communication. Number 7, rotate all agent credentials automatically. If rotation requires a human, it won't happen. And number 8, log everything. Every agent request, every scope used, every resource accessed. You will need this when something goes wrong. Three things to remember. AI agents break every assumption traditional API security was built on. Identity, scope, and monitoring all need to be rethought from the ground up. The good news, the patterns and tools exist today. You just need to implement them before your agents outgrow your security. If you want the deep dive with full code examples, check out the blog series linked in the description. Subscribe for more practical security and AI engineering content. See you in the next one.